I'm now going to give a brief introduction to graphs. We're going to do a lot of graphing in this course, and in your future courses you're also going to do a lot of graphing. But for now we're just going to talk about briefly what graphs are. So remember, for a function that you always have an input and an output. And if a certain input, when you put it into the function, gives you a certain output, we can connect together those two values, the input value and the output value, and we'll plot them on the Cartesian planes, on the Cartesian plane as the x and y coordinates. Now, for instance, we might take a look at a function like this, x cubed minus 3x plus 2. And this is the only time I'm going to do this in the course. I'm actually going to plot this function just by plotting a few points and connecting the dots. This is not generally a good idea, but we're going to have to start somewhere. Now, if you plug those x values there, -2, -1, up to 2, into our function, remember our function is up here, okay, and we calculate the y values, these are the y values that we get. Okay? So I can plot those points. I can think of -2, 0 as being a certain point in the Cartesian plane. Now, when we draw graphs in this course, I'm not too worried about having every tick be exactly 1 unit and all my units getting listed. Instead, I just want to put on the important values. So here, I've got 0, 2, and 4, and -2 and -4 as important y values, and 1 and 2, and -1 and 0, of course, and -2 as important x values. And now we'll just plot the points. Our first point was -2, 0, so that's right there. Then -1, 4, then 0, 2, 1, 0, and then 2, 4. Now, if you look at those points, they seem just kind of scattered about the page, and really they are. We have no logical reason to connect them in any particular way. But I happen to know a little bit about this type of function, and I know that it looks like this. Now, later in the course we're going to have to do a lot better than this. But what the graph of this function is, it's all those points, all the possible inputs. If we look at our function, the domain is all real numbers. We don't see any even roots and we don't see any denominators in our function, so all real numbers are going to be the domain. And for each one of those infinitely many different choices, we get a unique output. Those are our y coordinates. Okay? And in fact, our range for this function is going to be all real numbers. So the graph is just the collection of all those infinitely many points. They form this nice curve, the green one that you see there. Now, I'd like to briefly define what intercepts are. Again, we don't know enough yet to really talk too much about how to figure it out, but I'll tell you kind of the general process. So a y-intercept is a point of the following form. It's got an x-coordinate of 0, and so that means its y-coordinate is found just by plugging 0 into the function as an input. Now, of course, we can only do this if 0 is in the domain of our function. Okay? Otherwise, of course, we can't plug it in. So again, to find a y-intercept, all you do is plug in x equals 0 into the function. Okay? So we have a little recipe on how to find y-intercepts. An x-intercept is the flip side of that. It's a point on our graph whose y-coordinate is 0. Now, a graph may have lots of x-intercepts, even a graph of a function. It also may have none at all. I've got a little short form here for x-intercepts. Now, to find the x-intercepts, you set y equal to 0. In essence, what you're doing is solving f of x equals 0 for x. Okay? Now, we should have no problem plugging in x equals 0 to find y-intercepts, but to solve f of x equals 0 for x to find the x-intercepts, well, we're going to have to do a lot of studying to figure out how that works for all sorts of different types of functions. So the examples I'm about to do, I don't expect you to know how to do them right now, but as we progress in the course, you will learn how to do each one of these things. Okay? So if I start off with my first function, that f of x equals 2x squared minus 6x plus 4, if I'm interested in finding the y-intercept, all I do is plug in x equals 0. So if I plug 0 into my function f, I'll get 4. Okay? So the y-intercept it's 0, 4. I'll always give both coordinates of the point. If I just wrote y equals 4, that could be mistaken for the horizontal line y equals 4. So in this class, I expect you to do the same. All of your intercepts should be coordinates with points with two different coordinates. Now for the x-intercept, things are a lot more interesting. This time, f of x is equal to 0. So I've got 2x squared minus 6x plus 4 equals 0. That's a quadratic equation, and we need to solve it. Now, I don't expect you to know how to solve it yet, so don't worry if you don't know how to do this, but I'll go through some steps, and we'll talk about how to solve this in the very near future. Okay? But I soon discovered that there are two solutions to this equation. X equals 2 and x equals 1. That means we've got two x-intercepts. So again, I'll give both coordinates of the x-intercepts. So I've got 1, 0 and 2, 0. Now if I move on to my next function, we've got an absolute value function. What those absolute value bars mean are whatever is in between them, whenever it evaluates to a negative number, then change the sign and make it positive. If what's inside them evaluates to a non-negative result, then just leave it alone. Okay? So if I find the y-intercept of my function g, I'll plug in x equals 0, and I'll get the absolute value of negative 7. Well, notice there's a negative number inside those absolute value bars, so it changes it to a positive 7. Okay? So that means our y-intercept is 0, 7. Now, if I want to solve the equation, absolute value of 5x minus 7 equals 0, turns out I need two cases. Now again, you don't need to know how to do this now. I just want to talk about the idea. All I want you to get out of this is to find the x-intercept. You set the function equal to 0 and then solve for x. How you solve for x is something we'll need to talk about later in the course. So we end up with two different cases. And from our first one, we get that x is 7/5. And from the second one, we get, strangely enough, the same result. Okay, and we find that, so here 7/5, 0 is the unique x-intercept. All right, now for our last one, here this is a radical function. Okay, for our y-intercept, we're just going to plug in x equals 0. You should be able to do this. And we get negative 0, that's 0, plus 3 times the square root of 0. The square root of 0 is 0, plus 10. Okay, so the y-intercept is 0, 10. And for the x-intercept, what we do is set this function equal to 0 and we solve for x. All I expect you to be able to do at this point in time is just set up that line we've got written right there. Okay? Now you have a problem of solving that equation. You don't know how to do that yet. I'll show you much later in the course how to solve a radical equation. But for completeness, I'll just do it right now. You can look back at this later in the course as an extra example. So I'll isolate my radical term, move everything over to the other side, square both sides. Okay, and then bring everything over to the right-hand side there. And now we'll factor that right-hand side. And that gives us two solutions, or at least two candidates. However, if you check out the x equals 4, in the original equation, turns out it doesn't work. Negative 4 plus 3 times the square root of 4, that'd be 3 times 2. So it'd be negative 4 plus 6. That gives us 2 plus 10 does not equal 0. Okay? But if you plug in 25, we get negative 25 plus 3 times the square root of 25. So that's negative 25 plus 3 times 5 plus 10, we do get 0. Okay? That means that 25 comma 0 is the x-intercept. Okay? So again, just to recap, all I want you to know at this point is the definition of the x and y-intercepts. The y-intercept is the easy one to find. You just take your function, plug in x equals 0, calculate. The x-intercept is much more difficult to find. You set the function equal to 0, and then you have to solve that equation for x. And as I mentioned before, don't forget to report on both coordinates for your intercepts. Thank you.